detection system in service type solution today. I will talk about the necessity of leak detection system presence, our solution, what is important from the point of view of customers, what other type of solutions are in market, what are the benefits of this kind of system for customers, how the service model is constructed by our opinion, what are the system outputs, what are the technical components. I will talk about the limitations. I will show our references in this field as activities. What is the scope of the leak detection system? We elaborated this leak detection system for pipeline transporting basically liquids or natural gas. The main scope is to detect the enemy's activity is again the pipelines as soon as possible, to localize these events and to make the measures to minimize the effects of the leakages events. What kind of problems we can occur in the pipeline operation? The first of all is the operational type accidents. There are several natural disasters, and the third-party activities. Basically, there is the theft activities, the product, the crude oil, the gas oil, and other type of products. Theft from pipelines, and there are also mechanical and corrosion problems. These pictures are made in December last year. There were a serious problem in Mexico. The most important effect of the leakage of the leakage events, the pipeline accidents on the pipelines, are for the surface. For example, a single leakage event in 2009 produced damage in an area of 10 hectares. 100,000 square meters. Yes. This was produced in operation area of concave organization. This organization collects information from 7 key pipeline operators. What kind of accidents we can observe in the pipelines according to the concave reports? There are several mechanical problems, corrosions, natural disasters, or we can observe approximately half of the accidents are thefts. Basically, third-party activity are thefts from the pipelines.
This is for a country or worldwide?
This is a concave organization from 70 operators, 160 pipelines, 3,400 kilometers. There is only for pipeline operators associated with concave organizations. In other regions, for example, in last year, in 10 months was produced more than 600 accidents, third-party events, basically. And here is a graph containing the sustained product in million barrels. What is our solution? We developed a leak detection system based on hydraulic model. We developed our special transducers, field controllers, central system, cloud-based central system. We have a special operation philosophy. I will talk about the system concept and the performance and about the legal proofs that we made 2 years ago. When we made these legal probes together with a TÜV company from Germany, we observed the pressure wave traveling 35 minutes along the pipeline, basically traveling the distance between Budapest and Moscow. From this purpose is able to make leak detection based on hydraulic events detection. Here are the characteristics of our pressure transducers. Basically, these transducers are used in aviation, exactly the same, but for gas application, Balázs present to you. We developed our special field controllers in order to process data in the field, to communicate this data by GPS communication to a central server, and in the field to synchronize the timestamp, because the timestamp is very important for us. For each pressure value, we put the timestamp of the pressure value together, and then we will process this value in order to detect the leak detection events. The central system is cloud-based, and we process all pressure data transmitted from the field, from field devices, by the field devices. We make the necessary calculations to give the location of the and the system is developed basically to detect the small thefts of products, not only to detect the ruptures. There is necessary to have a SCADA system installed, or to construct communication lines, or to have a leak detection specialist on the customer side. Let's have a look at the system concept. Along the pipeline at the well stations, we will install our special devices, field devices. We use GSM-based GPS communication to transmit this data to the cloud computer. The customer monitoring station will access this data. We will make the necessary analysis daily, and the results will be transmitted to the customer. On the customer side, there is a computer for configuration of the necessary data regarding the security, management of different type of data, and to make the necessary visualization of facts and events.
Most kéri a flipchat-et, gyorsan elszállt.
the concept of link detection as service. There are three types of solutions, complex solutions. One of them is when we install the field devices in fixed mode. We install this type of devices, and all other things are the same, but I say the second one is when we use mobile devices for analysis for a small time period, few days. We install mobile devices. We have a lot of mobile devices. The communication is the same, GPS, and the rest is the same. And the third one is concepted when we make special measurements, and we not use communication, GPS or other type of communication. We use mobile devices and with on-site data collection. We use basically computers to collect data, and these data are introduced in the central server, and from the server we will make the analysis and we make a documentation, and this documentation will be transmitted to the customers. By our experience, we can observe a pressure variation of 2 millibars on the pipelines in steady state when the transportation is stopped. During the transportation, the pressure variation that we can observe must be three times greater than the pipeline pressure noise, because in every pipeline, from mechanical and from electronic reasons, there is a pressure noise present. Also in steady state during transportation. But it means, for example, if the pipeline has a value of 10 millibars, we can observe a pressure drop 30 millibars. The response time, of course, depends on the length of the pipeline. Because we must collect all data from all locations. If we have only 4 or 5 locations, the pressure wave propagation will be 1 minute, for example. For the biggest pipeline is 2, 3, 4 minutes. It's necessary to collect all information. Yes?
Sorry, what's the maximum length or distance between 2 detectors?
Between 2 detectors? We like 30 kilometers to be maximum. 30, yes. But in several cases we use 50 kilometers between them. If it's not possible to put another sensor between them, also we can use with a large distance, but the sensitivity will decrease in this case. We made legal probes assisted by 2 institutes, by the TÜV Reinhardt and the Department of Fluid Mechanics of the University of Budapest, Technical University from Budapest. They reported this.
'These concrete,
2 institutes, 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 2 sensitivity limits. In steady states, we observed falling the pipeline. We made pulls 0.7 millimeters. The extractive volume was 1.2 liters only. The pressure was 3 millibars. During the transportation, we observed the theft made by us, the 1.5 millimeter hole and 4 liters was still from the pipeline. What is important from point of view of sales are the benefits for the customer. There are no original investments regarding the service type of twisting compression system. There are no necessary to have trained personnel, no investment risks, and Carson will give technical support in each cases. What other type of solutions are in the market? We can categorize in two. There are several intermittent solutions. Then the theft of the product is observed. At the moment when the area surveys and order one survey is made, or the intelligent bidding is made, very interesting is the acoustical leak detection made by a Canadian company, Pure Technology. Basically, the ball what is put inside the pipeline, and this will observe the different type of leakages along the pipeline, but only when this is in operation. It is not a continuity solution. And several chemical trace methods are used in other countries also, like in America. There are other type of solutions that are contained solutions like discrete hydrocarbon sensors, acoustic sensors, fiber optic sensors, or highly detection system based on the scanner systems. You can searching by internet to have some results, hydraulic leak detection solutions based on SCADA system, but these systems are basically softwares, only the main part, the central part. They use the normal pressure transmitter for this scope, yes?
Do we have a comparison of our system against these systems?
Yes.
Vis-a-vis advantages, disadvantages. Do we have we made any comparative statement?
If we compare our sensitivity to 2 millibars is not able to measure with a normal pressure transmitter. Only 20 or 30 or 40 millibars is able to measure. To make a difference between two.
The competition can measure up to 30 or above 30, right?
From 30.
Yeah.
30.
The question of the colleague was competition between Kaysen and others.
Yes. This is the main.
Sensitivity is 2 millibar and
yes.
the competition is 30 plus.
30 plus millibar.
10 years ago, we also used the traditional pressure transmitters. But we observed small leakages are not observable in this way. For this purpose, we developed our special field transducers for this scope to detect these small changes in pressure values. Who are our target customers? All pipeline operators. Basically the oil and gas operators, and also the water transportation operators are our target customers. On the Theodora.com website you can find other maps specific to your regions. I put here the European map of the gas and oil pipelines. There is a lot of pipelines, yeah? For introducing a service model, the first step is necessary to make preliminary measurements along the pipeline. After that, we will make the system implementations, and the leak detection system will be in operation in service after that. There are some conditions regarding the installation. The pipeline to be pegged, to have only fluid, to have not gases, enclosures in the pipeline. For this purpose, the minimum static pressure must be higher than 4 bars. And for communication, to have GSM availability for GHz communication.
Why do we need local power availability?
For that, also we can use our system without electrical power availability, but in these cases we cannot collect data. We cannot collect 5 kilobytes per second. Yes, we collect 5,200 measures in every second. Using
external power
over by using operation from batteries. We must change the batteries in every, I don't know how many days. It's possible, but in these cases it works only with 1,000 measurements per second.
without this.
Without electrical reliability.
We decrease the sensitivity.
Also, it's necessary to have some technical data about the pipeline. First of all is the piping and instrumentation diagrams. To know exact distances between the locations where the pressure sensors will be installed.
What's that? PNI?
Pipeline and instrumentation diagrams.
PNID.
PNID, yes.
Piping and instrumentation.
know the pipeline diameters, the flow rates, the product density. This is the basic this information what I need. And also the procedures, description of the operations, how the operator works with this pipeline. And also if possible to give us the maps of the pipeline. What is important, the preliminary measurement to make a site survey, to discuss with the future customers, and to make a measurement. What is the wave propagation speed in the pipeline? This is the basic information for us. For implementation, sure we must have a contract for this implementation. The technical conditions are the same. We will mount the devices with the support of the customer. We will set up the central system with different parameters, distances and other things, and the system will start up. In operational mode, the pipeline must be continuously packed full with liquid, and we must have sure the contact persons from customer side. The field data are transmitted to the cloud computer, where these data are stored in SQL database, and there are two types of analysis. One of them are made automatically in every 2 or 10 minutes, depending on the length of the pipeline, to detect the pipeline ruptures. The other one is made manually every day to detect the smallest leakage events during along the pipeline. What kind of services are available by the information system usage? There are some online and offline services giving to customer the following outputs: pressure trends, profiles, pipeline pressures. I will show an example from that. And several offline services, reports, historical pressure trends, or recommendations for pipeline operators. There is an online pressure trend. There is the several locations in this menu where installed sensors. There is a time period selectable, and there are 3 locations selected. On the horizontal axis is the time, and in the vertical is the pressure value in bars in this case. These are real values 2 weeks ago in a crude oil pipelines. Pressure profile. In the horizontal axis are put the locations. There is the elevation of the pipeline above the sea level, and these segments are the pressure values. And we can observe this pipeline is in operation, is transporting this pipeline. And here is a buster pump station, where, for example, the 5 bars inlet and the outlet is 50 bars. These are my pressure profiles. online pipeline pressures. The pump station, the beginning of the pipeline, different valve stations along the pipeline. This is the receiving point. Yes? And there are several pressure values measured online along the pipeline. Different kind of alarms are shown in this slide. Six from them are real cases. What kind of offline reports and outputs we have? We have an automatic alarm for intense pressure pipeline changes for pipeline ruptures. We have daily reports. We have a summarization of daily reports. We have recommendation for pipeline operators regarding the recommendations how to operate the pipeline, to make a pressure of 10 bars value on other things. There is a format of the automatic alarm report, number, customer data, pipeline data, what kind of event we detected in automatic mode, and description and recommendation, and other things. This type of report is generated automatically and sent in a recording mode to the customer. There is a daily alarm report. When we observe an alarm, this is made manually. We introduce the event description here, and we attach some trends or other event descriptions. This is a summarization, a weekly summarization containing different types of events during the week. Recommendations for pipeline operator, what we observed and what is the recommendation to make different changes in operation of the pipeline. And then there is the different type of attachment. When event detected, we can observe there are 4 locations, yes. There are several events detected, and we calculate from this site where the event was produced. This is a location calculation of location. The collected pressure trends are available historically to give, for example, here we made for 10 minutes. Also is an event, 5 locations. This is the pump station, this is the receiving station, and an event was produced near this blocking valve station. As you see, all reports are generated in electronic PDF format. We prefer to make contact with the customers in electronic mode by email in different web pages. As I mentioned, the pipeline rupture event will be transmitted immediately to the customer, and only for the nominated persons will be nominated from the customer side. What kind of system components are? There are field units, transmitter, leak controller, to process on site this data, time server to give the exam time synchronization, GPRS router for communication, switch, power supply, and IP66 enclosure. Another possibility, then we use batteries, what I mentioned. There is a possibility to use from batteries, but we used this type 2 years, but in other conditions with small, with 1,000 measurements per second. It is the central application for. There are some limitations, but I mentioned to have a back pipeline below basis. We have pressure transmitters in two ranges, one to 64 and to 200 bars. About the segment length, not more than 50 kilometers. Pipeline noise to be, if it's possible, below 25 millibars, and to have GPRS availability, if it's possible, to have 2 operators for the device. In this case, is no need for communication lines, but if the customer has communication lines, also we can use this one. And in this case, we will not use the GPRS router for this purpose. There are some references, more of them are in Hungary. All pipelines basically multi-product, diesel, jet, gas oil, special products, crude oil, and border with Ukraine also we have, and we made, like Chilo mentioned, we made a measurement pilot on Iraqi and Turkey pipeline. This is the diameter 1 meter